Okay, example number 3. A floodlight of mass 20 kg in a park is spotted at the end of a 10 kg uniform horizontal beam. So it is hinged to a pole here, and then a cable here is supporting the light. Okay, so sketch a free body diagram of the beam, and then the tension in the cable, and then the force exerted on the beam by the pole. We have to calculate lah. Right, so let's try to draw the free body diagram. So this is the beam, okay, the 10 kg beam, and then we are gonna draw the forces. So this is the light, and then this is the tension. Okay, and then we are gonna have a force here, and I'm not sure if it's called shear force. Don't actually remember exactly the name. I'll get back to you. I'll tell you when I found the right explanation lah. Tapi usually we label it as S. Okay, right. Lepas tu we have to also consider the weight of the beam kan, sebab dia cakap dia ada 10 kg beam, so we cannot neglect that value of mass lah. So but where exactly is the weight gonna be? The weight force is gonna be is at the center of gravity. Okay, so untuk uniform horizontal beam, center of gravity there will be in the middle lah. Okay, so middle somewhere around here lah tu. Okay, so that is the free body diagram yang kita perlu lukis lah. So this is S, and then this is theta, which is equal to 30 degree. This is S, this is 30 degree, this is the tension, this is mass of the floodlight, and then this is for the beam. Okay, and then the distance from here to here, from this point to this point, and then the whole length of the beam. Okay, so this is 0.5 L, this is just L lah, the length of the beam. Okay, so that is our free body diagram. Let me copy this, put it here. Okay. Okay, now let's try to solve question B, where we have to find the value of tension and then the value of force exerted on the beam by the pole. Okay, so the force by the beam on the pole, on the beam by the pole, I think. Okay, so before we start, we have to set a rotation point. Okay, a rotation axis lah. So in this case, we can let this point here, point O, to be the rotation axis. Okay, so untuk torque nanti itu, untuk torque kita akan tengok semua bahagian untuk torque saja kita akan refer to this point lah. Okay, right, so this time I'm gonna use a table. So this is the force, then we have X component, then we have Y component, and then this one is for torque lah. Okay, right, the first force is the weight of the floodlight. So X component dia equal to 0, sebab dia ada di sini 90 degree kan. So X component 0, Y component is negative MFG. Actually, I'm just gonna write negative 20, 9.81, so equal to berapa? Equal to 196 Newton. Okay, and then torque is force times displacement. Okay, so this is the force, and then remember the displacement should be perpendicular. The radius pula. The distance pergi the rotation point, which is rotation axis point O ni, should be perpendicular. Okay, so kalau macam ni, this is the force, and then we have to find the distance to the rotation axis, which is 90 degree di sini. So distance dia mana? Distance dia yang inilah. Okay, 0.5 L, half of the length of the beam. Okay, sebab kita mau distance yang up until this rotation point here. Okay, right, so force is negative 196 darab dengan, kejap, before that let me redo that one. Nanti kamu blur. Okay, so remember torque is force times dengan the perpendicular distance, perpendicular. Okay, so in this case kita ada force M F G. Okay, so darab dengan perpendicular distance there, which is 0.5 times dengan length of the beam, half of the beam punya length. Okay, now how do we consider dia positive atau negative? Is by using clockwise ataupun anti-clockwise. So sekarang ni beam ni, force ni untuk rotate pergi this point here, it is going clockwise. Okay, so if it is going clockwise, dia punya value will be negative. Okay, so that's why kita akan letak negative di depan. Okay, boleh. So this is just negative 196 times 0.5 L. Oh, I am choosing the wrong point instead of, oh yeah, okay, sorry ya, kejap redo dulu. So instead of letting point O to be this one, we should actually let it be here. Sebab sekarang ni kita tiada value of S pun, kita tiada the angle semua, so we should put the point yang we don't have any values. Okay, we don't have any values, so kita akan let that equal to the rotation axis. Kenapa? Sebab kalau kita cari torque, dia akan directly equal to 0 lah, torque untuk this point here. Okay, nasib belum continue yang lain. Okay, so this is point O. Okay, so that is the let O as rotation axis. Okay, so sekarang ni kita buat balik bahagian torque. So untuk distance yang ini, F darab dengan distance perpendicular, which is this one lah, so this is L. So dia akan jadi negative MFG darab dengan L, so negative 196 L jawapan dia. Okay, now we can use MBG pula, continue. Okay, so X component 0, and then Y component is negative, beam is 10, 9.81, so dapat negative 98.1 Newton. Okay, right, lepas tu torque dia pula sama juga, this is the force, this is the distance yang 90 degree, which is 0.5 L. Okay, so this is negative 98.1, dia pala equal negative sebab dia clockwise sebab dia clockwise, so tulislah negative MBG darab 0.5 L should get negative 49.1 L. Okay, lepas tu sudah tu kita tengok tension pula. So tension for X component is negative T cos 30 degree. Y pula T sin 30 degree. Okay, and then torque. Now we can look at torque pula. So untuk yang torque bahagian ini, kita akan tengok, kita akan resolve dulu dia sampai dia jadi perpendicular. Okay, so if we are using this, we are gonna let it pergi di sini. Okay, so tension dia should go up, Ty lah, Ty component, supaya kita dapat guna distance yang ini, sebab kita perlu cari perpendicular distance. Okay, so this is the distance that we will be using, so L. Okay, so Ty ni equal to apa? Equal to T sin 30 degree. Okay, so T sin 30 degree darab dengan L lah jawapan dia. Okay, so it's basically 0.5 TL. Okay, kalau kita buat T cos 30, dia akan go di sini, which will pass through this point O here. So bila dia passes through this point here, dia akan equal to 0. Torque untuk point T T itu akan equal to 0, which is what we don't want. We want to find the value of tension. Okay, that's why kita akan cari yang perpendicular. Okay, perpendicular. Okay, so lepas tu kita untuk point S lah. So S is just SX, SY sebab kita tiada lagi direction angle dia tu, kita tiada lagi. So kita just akan put SX and SY. And then since the force is at the rotation point ataupun rotation axis, dia akan equal to 0 lah. Torque dia akan equal to 0. Okay. Right. Lepas tu we can then find the tension and then the value of S lah. Okay, so kita akan let total torque to be equal to 0 at point O to be equal to 0. So this is just negative 16 L minus 49 L plus 0.5 TL equal to 0. So we can then get the tension to be equal to 490 Newton. Okay. Then the second question, we have to find SX and SY. So we can let total force at X is equal to 0. Negative T cos 30 degree plus SX equal to 0. So SX is just basically 424 Newton. Okay, and then we are going to use the same thing untuk Y component. So this is 196, 98.1 plus T sine 30 degree plus SY equal to 0. So SY is basically equal to 49.1 Newton. Okay, belum habis lagi. We have to find the magnitude, which is S equal to SX square plus SY square. Okay, so dapatlah jawapan dia 427 Newton, and then the direction is shift tangent SY SX equal to 6.61 degree. Alright, okay, so that is how you solve for question with torque.